Blessed day, everyone. Let us talk about fire protection and arson investigation. This lesson will discuss the basic concepts of fire technology, which includes the definition of fire, the chemistry of fire, the elements of fire, and the causes and behavior of fire. This will provide an understanding on how fire is produced and its effect to human and their properties. This lesson will also provide activities and exercises that will assess the students' knowledge on fire technology. For the intended learning outcomes, at the end of the lesson, the students must have to discuss the importance of fire and the contributions or inventions of different personalities for the development and producing fire. Illustrate and discuss the theories of fire. Identify and discuss the different elements of fire and their classifications. And classify fire according to its causes and the burning fuel. Let us proceed to the importance of fire. Fire is a source of warmth and light. It is used to warm themselves against cold during winter season. You have already experienced during December and January, we really want to have a campfire as we talk or mingle with our friends or even with our family members. Fire is also used to protect themselves against their enemies. It is a tool to combat enemies like wild animals because it degrades the performance an enemy force below the level needed to fulfill its mission. Fire also causes chemical changes to foodstuffs to suit man's body structure. It is used to cook food to eat. So, what food do we want to cook and eat? Probably the food we want requires cooking, which want to use the gas stove or to cook using the firewood. Fire also provides the process of modifying chemicals into medicines. Medicine has chemicals that requires heat to process. And when something is burned, the physical state or appearance will change because fire provides heat to convert wood, metals, and bones into domestic tools or instruments for aggression. Just like when wood is exposed to the flame, the wood gives off energy until the wood becomes charcoal. The gold may also or can be melted through exposure to heat, and they can transform the gold into a gold jewelries. As I already mentioned a while back, since fire produces heat, heat helps convert woods, metals into another substance necessary for another usage. What are the two early methods in producing fire? The early methods in producing fire are the following. First is the friction method. Friction raises the temperature of a combustible material, or we call it as kindling, to ignition temperature. And then the second one is the precaution method, which produces a spark to set a kindling of fire. So let us talk the early methods. Under the friction method, we have the fire laugh. It is the simplest form of primitive fire making using only natural materials. You will not use here match or even a lighter. It is essentially an optimized way to rub two sticks together, with the base board being one and the flow stick being the other. There are two sticks rubbed together, so when two things are collided with each other or rubbed together, heat will produce, and once it reaches its ignition point, it will create fire, or the fire will take place. Just like when you rub also your two hands together, it produces heat. Next is the hand drill. A hand drill is a bushcraft technique that is simpler to build than the bow drill, but it will require greater energy, patience, and skill to implement. All that is required is a drill in a fireboard. The stick being used for the drill is spun between two hands instead of using a bowspin to drill to generate enough friction to create embers. A hand drill is a simple tool used to ignite a pile of dried tinder. Because hands create less friction than a bow drill, this method is only effective in hot climate when wood is very dry. Otherwise, it will generate more energy. It will generate more time before a fire will take place. Next is the bow drill. This method is more complicated to build than either of the previously mentioned methods. The concept of the bow drill is as simple as well. A bow is constructed to rotate the drill while it rests on the notch fireboard. The pressure and friction created by the quickly moving drill produces heat in heated wood powder that will fall on the pile of the tinder placed underneath the fireboard. However, once a bow drill is built, it requires less exertion to create a usable ember. When we say ember, it is a small piece of burning or glowing coal or wood in a dying fire, which goes to the state of smoldering phase. Then the fourth one is the pump fire. The pump fire drill is the most difficult to construct of all the primitive fire starting tools, which generate more time. This is due to its more mechanically complicated nature. But things, what can this compensate to a person who wants to make a fire? Because it will lessen the time or even the energy to create a flame. Okay? Next is the precaution method. It is the second early method in producing fire. As I already mentioned a while back, precaution method produces a spark to set a kindling fire. So, this is the easiest of all bushcraft fire starting methods. All that is required is a flint and a piece of carbon steel, such as your survival knife. And we call this as the flint and steel. Okay, just just like what is shown to the in the slides. How these two objects, it could be metal to metal or to stone to stone. Okay, because when these two collides together, it creates sparks. But you need also, of course, a dried leaves here or very dried woods. Much better if these are already cut into pieces, so that when the spark will take place, the dried leaves will absorb now the uh, reaction coming from the uh, two objects. So here are the important personalities in uh, in the history of fire and their inventions. First is John Walker. He is an English pharmacist who discovered through lucky accident that a stick coated with chemicals burst into flame when scrapped across his heart at home. He went on to invent the first friction match. That's why he is the first one who invented match in 1827. That's the beauty of doing something, and when you discover something, you will design and innovate. And the second personality no other than no other than Anthony Lavoisier. He is a French chemist who proved in 1717 that burning is the result of the rapid union of oxygen with other substances. As a substance burns, heat and light are produced. And that is a factually correct. When we try to lit or when we burn a combustible material, what do we see? The light. And what do we feel? The heat. And the third one, Thomas Alva Edison, an American inventor who was able to send an electric current through a carbon filament or the wire until the filament becomes so hot that it gave off light. Have you tried to replace or remove the electrical bulb? If you try to touch it, or when you touch the bulb to remove it from the socket, you will feel the heat. Or sometimes when the bulb or the light is already switched for more than 30 minutes, when you try to touch or when you touch the bulb, it's hot or you will feel the heat. Fires start when a flammable and or a combustible material with an adequate supply of oxygen or another oxidizer is subjected to enough heat. So what is meant by fire, or what is the definition of fire, or what is fire? Fire is accompanied by light and heat energy, such as rapid oxidation of combustible material. The heat and light that comes from the burning substances produced by the combustion of substances, which is accompanied by a release of energy in the form of heat and light. So when we say combustible material or combustible materials, these are any materials that store energy that can later be extracted, just like also the wood. When wood is exposed to heat, it gives off energy, and that energy is the vapor that is being burned. Likewise, it is the manifestation of chemical process in which combustible matters combines or combine with oxygen to produce heat and light. Such rapid chemical reactions releases energy which in the form of heat and light. When a substance burns, heat and light are produced, as I already mentioned earlier. The light is in the form of a flame, which is composed of glowing particles of the burning material and certain gaseous products. You might already observe that the lighted candle can produce light. This lighted candle may also become our source of light when there is a power interruption. Gas stove, for example, or a Bunsen burner, releases gaseous particles, vapors. As I always mention, vapor is what is being burned and not the object, not the combustible material. So, what is the distinction? Is the state, process, or instance of combustion in which fuel or other material is ignited and combined with oxygen, giving off light, heat, and flame. While flame is the burning gas or vapor, as from wood or coal, that is undergoing combustion, a portion of ignited gas or vapor. In short, fire refers to the state, while flame refers to the result of the state. The flame is the visible when fire takes place, because flame is the incandescent gases. It is the very bright or glowing with intense heat. Remember, when three elements of fire that we will be discussing later merge together, there is a chain reaction. When chain reaction will take place, here comes now the fire. And fire produces heat. When a combustible material is exposed to heat, it gives off energy, it releases energy, or it gives of vapor, or it releases vapor. When this vapor is now uh, being burned, it shows already the presence of the flame. Okay, so flame, it is the gaseous part of the fire, which we can say that flame is also a fire. But fire cannot be said to be a flame. Okay, so fire, it is the oxidation of organic material. Fire is the process in which the combustion organic material takes place, releasing energy in the form of heat and light. Now, let us talk about matters. Okay, matters that will exist. All matters exist of one of the three states: solid, liquid, and gas, or the vapor. In a solid, the particles, the ions or atoms or molecules are closely packed together. The forces between particles are strong so that the particles cannot move freely but can only vibrate. As a result, a solid has a stable, definite shape. You can tell what shape is that object, and a definite volume. You can able to determine the quantity. So in order for this solid to change its shape, it must be done through force. like when you cut the solid into pieces or break the solid, or you can make use of the fire. Okay, that is the solid. While liquid is a nearly incompressible fluid that conforms to the shape of its container but retains a nearly constant volume independent of pressure. The volume is definite if the temperature and pressure are constants. Remember, when a solid is heated above its melting point, it becomes liquid, given that the pressure is higher than the triple point of the substance. Just like also the uh, ice cubes. That is a solid when still at the freezing point. But when it is exposed to heat and it reaches the melting point, becomes liquid. Okay. Next is the vapor. The spaces between gas molecules are very big. Gas molecules have very weak or no bonds at all. The molecules in gas can move freely and fast. And when this exposed to heat, these molecules or even atoms will collide each other, which creates more or releases more energy or the vapor. So this is only a recap of what you have learned during your senior high or even during your high school. From solid to liquid, we call it as melting. From liquid to gas, we call it as vaporization. And when solid becomes gas, we call it as sublimation. And when gas becomes plasma, we call it as ionization. Plasma, these are electrons are ripped away from their nuclei, forming an electron sea. This gives it the ability to conduct electricity. Remember, we use uh, the diesel or even gas to generate the performance of the vehicles. Like a gas, plasma does not have definite shape or volume. But unlike gases, plasmas are electrically conductive, produce magnetic fields in electric currents, and respond strongly to electromagnetic forces. Positively, charged nuclei swim in a sea of freely moving. The associated electrons similar to the way such charges exist in conductive metal. So, in fact, it is the electron C that allows matter in the plasma state to conduct electricity. Let me just give emphasis on the plasma. The plasma state is often misunderstood, but it is actually quite common on Earth. And the majority of people observe it on a regular basis without even realizing it. Lightning, electric sparks, fluorescent lights, neon lights, plasma televisions, some types of flame, and the stars are all examples of illuminated matter in the plasma state. Okay? So, plasma becomes gas, we call it as, liquid becomes solid, we call it as freezing. And gas to liquid, we call it as condensation. Then gas to solid, we call it as deposition. And plasma to gas is the recombination. will oxidize. Substance will oxidize when surrounded by oxygen molecules. The molecules of solids or liquids are too tightly packed to be surrounded. However, when a solid or a liquid is heated, its molecules move out rapidly. If enough heat is applied, some molecules break away from the surface to form a vapor just above the substance. Remember, based on what I just mentioned earlier, when a combustible material is exposed to heat, and when there is enough heat applied, it will generate, or the combustible material will generate vapor, or it will releases vapor. I have here a question. Thus, is only the vapor that burns? The answer is yes. It is the vapor that is being burned. So let us talk about the elements of fire. First element is fuel. For a fire to start, there must be something to burn. You are not like the Reika in the animated series named or entitled Flame of Reika, which there's no need for a combustible material before fire will take place. Here, it requires something to burn for a fire to start or will take place. The physical state of the fuel may be gases, which includes natural gas, propane, butane, hydrogen, and the like. Liquids, which includes gasoline, kerosene, turpentine, alcohol, paint, varnish, lacquer, and the like. Or solid, which includes coal, wood, paper, cloth, grease, and the like. It is the combustible material. The second element is the heat. Heat sources include open flame, hot surfaces, sparks and arcs, friction, chemical action, electrical energy, and compression of gases. So for a fire to start, there must be a source of ignition, usually heat or a spark. It is the ignition temperature. Next element is the oxygen. A source of oxygen is needed, approximately 16% is required. Let us discuss further the elements of fire using the illustration. Fire triangle and the elements are necessary for most fires. The triangle illustrates the rule that in order to ignite and burn, a fire requires these three elements. Just also in the revised penal code, all elements must be present before there is a crime committed. If one element is not present, then there is no crime committed. The fire is prevented or extinguished by removing any one of them. A fire naturally occurs when the elements are combined in the right mixture. Heat is required to ignite a fire and will continue to be generated as the fire burns. For intentional fires, this could be as simple as the striking of a match or when a person uses a lighter. Fuel can be anything that is combustible, such as wood, petroleum, and spirits, and a number of gases. However, solid fuels requires critical temperature or high temperature in order to ignite. But those liquids, it will release flammable vapors even when cold or even at the low temperature. While in the oxygen, the air feeding a fire only needs to be made up of 16% in order to react with the heat and fuel. So air comprised of 21% of oxygen, 78% of nitrogen, and 1% of inert gas. So let us find out what percentage of oxygen that requires or may support combustion. 16% or 21% can support fire point. 14% to 15% oxygen can support flash point. 12% oxygen insufficient to produce fire. Then 21% is the normal oxygen. Okay, so before a fire will take place, it requires 16 to 21% because the first one that will take place is the fire point. Okay, then after the fire point, when the burning material or when the combustible material is already burned, for it to meet the flash point, it requires at least 14% or 15% oxygen because the burn materials has the uh, the heat or comprise already or contain already with a heat, okay, or heat state. So when these elements are merged together, that's the time the fire will take place. But when one element is not present, it will not, or the fire will not take place. But we have here the fire tetrahedron. We'll discuss in details how fire will take place. Because when the three elements, the oxygen, heat, fuel, merge together, it will create chain reaction. That the chain reaction keeps the other three pieces from falling apart. Okay, so just like also in the forensic ballistics, before an exterior behavior will take place, there must be the intermediate behavior. Okay, you will soon know the branches of ballistics. But before a fire will take place, there is the chain reaction. Okay, remember in science, when there is an action, there is always a reaction. So when three elements merge together, what do you think will happen? Of course, there will be a chain reaction. And now, here comes the chain reaction. It will now make the fire exist. It will make the fire exist. So what is really meant by chain reaction? It is the start of burning, or the start of burning is the start of a chain reaction. Okay? Vapor from heated fuel rises, mixes with air, and burns. It produces enough heat to release more vapor and to draw in air to burn that vapor. Okay? So, the start of burning is the start of the reaction. Until it reaches already the ignition point, now fire is taking place. So, how can we extinguish fire? We can only extinguish fire by removing one of the elements of fire. Because if one element is not present, fire will not exist. Now, let us remove either of the following: energy or the heat, oxygen, and or the fuel. So removing the energy or the heat. Without sufficient heat, a fire cannot begin and it cannot continue. Heat can be removed by dousing with water. The water turns to steam and the steam is further heated, taking the heat with it. Just like also the method that is being used by the firefighters, they use water to extinguish the fire. Then next is to remove the fuel. Without fuel, a fire will stop. Fuel can be removed naturally, as where the fire has consumed all the burnable fuel, or manually, mechanically, or chemically removing the fuel from the fire. Here is the scenario. There are three pieces of wood. Wood A, wood B, wood C. And they are all adjacent together. Wood A is currently being burned. If there is a way to put off the fire using chemical, then so be it. If there is no other way to prevent or to put out fire by removing the fuel, then you need to remove wood B and wood C from the area and allow wood A to be consumed by fire. Because when there is no more vapor or fuel or the source of fuel, the fire will automatically will automatically perish. Okay. Next is you may also remove the oxygen. Without sufficient oxygen, a fire cannot begin and it cannot continue. With a decreased oxygen concentration, the combustion velocity gets lower. So there are ways on how to extinguish. You can make use of cooling. When we say cooling, it is the removing of heat, which is the most effective methods of fire extinction available. That is why water is a popular extinguishing material. Next is the starving. While cooling removes the heat or ignition element of the fire triangle, starving the blaze of its fuel source approaches extinction from a different angle. A raging fire will burn itself out if it runs out of flammable materials such as bonfire out in the open that is not in contact with any other woods or dry grass. Then next is the smoldering as the other key component present in the chemical reaction that causes combustion. Removing oxygen from the equation is the final way of extinguishing a fire. For example, smoldering a frying pan blazed with a fire blanket reduces the oxygen to below 16%, while covering a candle with a glass will snuff it out in a vacuum. Next, let us proceed to the basic concept of fire. When the temperature is very high, it releases highly combustible vapors. This known as free radicals. Now, as more vapor burns, is the flame production increases? The answer is yes. More heat is produced, is less vapor released? The answer is no, but it releases more vapor. As I mentioned, when combustible material is exposed to heat, it will release vapor. When more heat is applied, more vapor is being released. Now, more air drawn into the flames and more vapor burns. Is the chain reaction keeps increasing? The answer is no. It will only gives a chain reaction after or when the three elements come together or merge together before the fire will take place. Then the size of the fire increases until fuel is consumed. Okay, going back to my example a while back, when the wood E is totally consumed, the fire will automatically perish. So what is meant by combustion? It refers to the oxidation reaction that produces fire. If oxygen supply is sufficient, there is rapid oxidation resulting to complete combustion. Combustion generates light, heat, gases, and soot. If there is sufficient oxygen, then there will be smoldering fire. So a smoldering refers to the slow or low temperature flameless form of combustion. This happens when there is no more fuel that is being consumed, or when the fuel is totally consumed. There is no fire, but there is a smoke, flame, as well as heat. It's sustained by the heat evolved when oxygen directly attacks the surface of a condensed phase fuel. Modes of fire. First is the surface or smoldering mode. It is the glowing combustion manifested by embers. And when we say embers, are those hot pieces of or lamp that remains after material has partially burned and is still oxidizing without the manifestation of flames. The smoldering mode shows that the combustible material has no longer has no flames, but it has heat, light, as well as the smoke. And the second mode of fire is the flaming mode. It is the gas phase combustion or flame, combustion flame. It is already the illustration or demonstration of the fire tetrahedron. It is already a stage where the fire is taking place. Now, what is the distinction between flammability and combustibility? Flammability, it has a flash point of below 98 degrees Fahrenheit or 38 degrees Celsius. While combustibility, the flash point is above 98 degrees Fahrenheit or above 38 degrees Celsius. In short, flammability or flammable substance is easily ignited and capable of burning with great rapidity. It is therefore a highly combustible substance. While combustible or combustibility, it requires higher than the normal temperature to ignite. So, in short, flammability is more ignitable than the combustible. So that's all for this lesson. Thank you so much.